Question 1 on functions. We need to find g fx, so we're going to substitute the whole of fx into wherever we see an x in g, so in there and there. That will give us 2x plus 3 all squared minus 2 times by 2x plus 3 plus 1. We'll need to simplify that, so if we do double brackets here, we get 4x squared. We'll get 6x plus another 6x, so that'd be 12x plus 9. This will give us minus 4x. Minus 4x minus 6 plus 1. Simplifying everything, we get 4x squared plus 8x plus 9 takes 6 is 3 plus 1 is 4. And we could probably take a 4 out of everything here. And then this is x plus 1 all squared. So probably the easiest answer is to write it like this. We do need to find the domain though now, which is slightly awkward. Let's do that in a different color. We know the domain of fx is x is less than 0, and we know the domain of gx is x is greater than 1. So when we put all of fx into a gx like we did up here, we need this 2x plus 3. This 2x plus 3 must fit with the domain of gx. So in other words, 2x plus 3 must be greater than 1 in order for us to substitute it in to gx. So if 2x plus 3 has to be greater than 1, that means 2x is greater than minus 2 and x is greater than minus 1. Excuse me. So in order for it to fit the domain of fx, this must be true. In order to fit the domain of gx, this must be true. So therefore the domain of g fx satisfy both of these, so it is between minus 1 and 0. In part B, we need to find the range of gfx, the range of this. Now we need to bear in mind that x is between minus 1 and 0. I think the best way of doing the range is to think what the graph would look like. So if we want to sketch the graph of this gf of x, then we're only sketching it between 0 and minus 1. So when x equals 0, when we put 0 into this equation, we're going to get 4. And when we put minus 1 into this, the bracket will become 0 and we'll get 0 out. So sketching the graph of this, I think it's clear that minus 1 is going to be the minimum point, and it'd be a happy quadratic. We don't actually need this region down here, but the graph would look like that. Okay, so this is the graph of g fx, and you can see that the domain is here, but we already knew that, and the range are the y values here, and the range is between 0 and 4. So the answer to B, the range is g f of x is between 0 and 4. This is the same inequality symbols as in the previous question. It can't be equal to 0 and it can't be equal to 4. In part C, we need to find the inverse function. I like to let y equal the original function. So g of x we did up here in part A. That is for x plus 1 squared. And then I like to swap the x's and the y's. So then we have x equals 4y plus 1 squared, and then rearrange to get the y's on its own. So rearrange to get y. So to do that, we'll do x over 4 equals this. Then we'll square root. So if we square root everything, we're going to need a plus and a minus. And so it'd be this. And then we could get y on its own. So, well, might as well just make this root x over 2, because the square root of 4 is 2. And so if we get y on its own, we'll get y equals plus or minus root x over 2 minus 1. Now we just need to, before we write the final answer with g f to the minus 1 of x, we just need to check whether we want this to be a plus or a minus, or whether we want it to be both. So in order to check that, we need to look at the range of this inverse function. Now let's do that in a different color. So the range of the inverse function g f all to the minus 1 of x is going to be the same as the domain in part A, the domain of the original function, which was up here. Okay, so the range of the inverse function is going to be minus 1 to minus 1 to 0. Okay, I'll just write down here it's the same as the domain in part A. So just looking at that then, if the range of this function here has to be between minus 1 and 0, excuse me, then this we don't want this negative, because that would make the answer less than minus 1. So we need to take the positive only here, and so the final answer for the inverse function is going to be plus, although you don't really need to write the plus down, it's going to be plus root x over 2 minus 1. That will be the inverse function. It doesn't actually ask us what the domain is, but often in these questions it does. If we wanted the domain of this, the domain of the inverse function is the same as the range of the original function, which was up here. So that would be, so the domain would be 0, 2, 4. As I said, we're not actually asked for that in the question, but often you are. Okay, so just make a note that is the same as the range in part B.